Hello friends, this question is from the subjects of EDC and the topic naming Basic of Optoelectronics. It's a common data question. It's the first part of the common data. In the problem it is given that a silicon Darlington transistor pair is shown in the figure and has a negligible leakage current. The leakage current we need to ignore. Okay, that's good. And it is given that the transistor beta 1 and beta 2 has a beta 1 and beta 2 is equal to 50. Both the transistor have a equal beta. Our VCC is 12 volt. RE, the emitter resistor of second transistor is given as 1K, and it is also given that our R2 is turned into infinity. So friends, what is the meaning of infinite resistor? Infinite resistor will be equal to an open circuit. So if R2 is infinity, it means that my IR2 is 0, because this connection is electrically equivalent to the open circuit, no connection. So in an open loop the current is 0, so my IR2 must be equal to 0. So let's come to the first problem. First problem says that find out the value of R1 needed to bias the circuit so that VCE2 is 6 volt. My VCE2 is voltage across this RE resistor is 6 volt. VCE2 is 6 volt. It is given as VCE2 is 6 volt. Okay, we will come to that. But before that, if my IR2 is 0, what means? It means that my entire IR1 is going to the base. It means that my IR1 is basically equal to the IB1. My base current of first transistor is equal to the IR1. Okay, and my IB2 is nothing but a emitter current of the first stage. So IB2 is also equal to IE1, because emitter terminal of first transistor is directly fed to the base terminal of the second transistor. So my IE1 is equal to the IB2. So now if we can see that my VCE2 is given as a 6 volt, now we can apply that the KVL at this path. So my IE2 will be equal to the VCC minus VCE2 by RE. You know that we know that the current across emitter terminal is IE, so its current across this terminal will be I. It's a second transistor, so I will note it as IE2. So voltage across, so my VE2 will be equal to the IE2 into RE2, right? So my VCE2 is collector to emitter voltage, and that VCE2 is given as a 6 volt, because in the collector terminal we have no resistor. So my IE2 will be equal to a 12 minus 6 by 1 into 10 raised to power 3, which is 6 milliamp. My IE2 is 6 milliamp. Now my IB2 is, we know that base current is related to the emitter current as IE by beta plus 1, or our general formula is IE is equal to the beta plus 1 times IB. So we know the emitter current of second transistor, so we can easily find out the emitter current of the first transistor, base current of the second transistor, which will be IE2 by beta plus 1. But in our case, the base current of the first transistor is actually equal to the base current of the second transistor is actually equal to the emitter current of the first transistor. The same value is equal to the IE1. Now similarly, my IE1 will be related to the base current of the first transistor as IB1 by beta plus 1. IB1 into beta plus 1 will be equal to the IE1. So now I can find out the IB1 as IE1 times beta 1 plus 1, or if I put the value of IE1, so it will be IE2 times beta 1 plus 1 or beta 2 plus 1. In our case, beta 1 and beta 2 are equal. So here this beta is actually beta 2, beta of the second transistor. So now if I can put all the values, IE2, which is equal to the, we have just calculated 6 milliamp. This both beta 1 and beta 2 are 50-50. So if I can calculate this value, it is equal to the 2.31 microampere. My IB1 is 2.31 microampere. So I need to calculate the value of R1. So R1 is what? So if I may apply the KVL at this path, so my R1 will be, if I can apply the KVL at this path, or I can take the different color, I can apply the KVL at this path from VCC to R1 through base 2 emitter voltage of the first transistor, and again base 2 emitter voltage of the second transistor, and then RE. We can always apply a KVL from VCC to ground. So in this VCC to ground, we have a one resistor R1. Across this we have a current IB1. Then we have a base 2 emitter drop, which is always equal to 0.7 in the forward bias. Then we have again base 2 emitter. This is also equal to 0.7 in forward bias. Then we have a IERE or IE to RE, which is equal to 6 volt. So I can easily apply this. I can find out value of R1 as VR1 by IR1. Here VR1 is VCC minus VBE1, which is 0.7, VBE2, which is again 0.7, IE2RE, which is 6 volt, upon IR1, which we have just calculated, 2.31 milliamp. So if you put all these values, you can get the value of R1 as 1.99 mega ohms. You can calculate the value of R1 as 1.99 mega ohm, because you know the value of VCC, which is 12 volt, VB1, VB2 constant 0.7, I2, RE2 is 6 volt, IR1 we have just calculated, because my IR1 is nothing but a IB1, because my IR2 is 0. My IR2 is 0 because R2 is infinite. So that's why my IR1 is equal to the IB1. So my correct option is option A. So correct option of this question is option A, 1.99 mega ohm. So this is the first part of the common data question. Thank you.